As it says, this is an open session, so you don't just need to be a Sumo employee to be here. Okay. So, around 40 years ago, a small boy, very excited, one Christmas morning, came rushing downstairs, big pile of presents. In that set of presents was one of these. Yes, it's a 16K Sinclair ZX Spectrum. Some of you have seen one. Some of you may have only seen one last night behind a glass case at the National Video Games Museum. That boy started playing some games, quite quickly got bored, and started asking questions like, how do these games work? Can I change these games? Can I make my own games? So, hard as it may seem, that boy 40 years ago was me. And yes, I got that Spectrum, I asked those questions, and it did sort of change my life and bring me to where I am today. I'm principal programmer at Sumo Digital. I have been programming since I was around 8. I started writing games for companies when I was 13. I joined Sumo Digital as a contractor around 12 years ago and joined as a full-time employee last year. Now, who would think writing games back in those days, or learning to program games back in those days, was harder than it is today? Or would you think it's harder today? With a quick show of hands, who thinks it's harder to program back then, harder to learn? And who thinks it's much harder to learn now? Now, you see, I'm going to go with harder to learn now. In some ways, that may seem odd. Nowadays, you've got Google, you've got access to books. If you have any question, you can stick it into Stack Overflow, and presto, there will be 100 people with an answer for you. Probably 50% will be wrong. 50% may agree with each other, and then they'll have a complete argument about why that is the right answer. So that does make things harder today. Back when I started, we didn't have that sort of problem. Hard as it may seem, we didn't have the internet. We had to learn by trial and error. So one of the things to consider as you go along your pathway is to remember the past, is to learn from the past, because it will help with the future. As I said, back in the day, we didn't have the internet, things were much harder. This was sort of the way I started programming. This isn't actually mine, I couldn't find any of my hand-code assembler. But as you can see here, we wrote assembler on paper. We then used a book to convert it into actual numbers, and then put those numbers in the computer. He ran it, it crashed, and this was very time-consuming. So we actually spent quite a long time looking at the version on the paper and working through it. And yes, I would say nowadays, we don't tend to use pen and paper too much, and it's well worth, when you're starting on something new, go back to pen and paper. You can do a lot of your initial debugging and a lot of your initial planning on the paper. And as you progress, you do actually have to start writing documents, and that itself will help you when it comes to producing the code. But as I say, that was a long time ago when I was doing assembler. As you can see here on this slide, back in the early 90s, Wolfenstein 3D, great game. It had started to have C, we did have some assembler. But as we progressed through the 90s, the amount of assembler in games got less. By the time we got to the late 90s, there was really no major assembler as such. So you could ask yourself, why would I stand here and tell you that it's worth learning some assembler? Well, around 2000, just after 2000, along came PlayStation 2. Now, we all agree PlayStation 2 for its time was a fantastic machine. It had a thing called vector units. The code here isn't highly relevant. It's just an example of some vector unit code. But you had to write it in assembler. Now, those of us that had learned assembler before, it was quite easy to learn vector unit coding. Because of the decline in assembler, people had forgotten or had not bothered learning it as they came into the industry, and it was a bigger step. A bit later on, along came shaders. Now, when shaders first came along, really, you had to write them again in assembler. But now, we have higher level shader languages. Even with PlayStation 2s, there are still people that write stuff on PlayStation 2s, and they've gone and written C compilers to write the code for you, because it makes life a lot easier. So, yes, why learn assembler? Well, I wouldn't say there's never going to be a time again when we're going to write entire games in assembler. They're too big. It would take too much time. But saying that, learning how to read assembler is still useful. Being able to do small things in assembler, it keeps coming back into fashion in some way, as we've seen back on PlayStation 2 it came in, with shaders it came in, and there's a chance that an assembler-like language can come back. Certain machines, some of the smaller machines that we have to work on, you do sometimes have to drop down to it. Optimizations. Now, a lot of you will say, well, we don't need to optimize in assembler anymore because compilers do such a great job. And yes, they do. They are fantastic compared to what they used to be. But they can only do a certain level. And even with shaders, you will find that, especially in shaders, for those of you who do it, the branching is not a particularly fast operation. You can slow your shader down quite a lot with some branching logics. If you take the time to look at the assembler that the high-level shader compiles to, you will actually be able to see where these things are appearing, and you can use that to tweak your high-level shader language to basically just to give the compiler a few hints as to what would be better. I'm not saying take the high-level shader language, take its assembler output, and start going from there, but just look at it and see if you can tweak your code to help the compiler along. And one of the biggest things as you progress along the pathway, the bugs you tend to have to get involved in get worse. Final build bugs are always the worst bug you can get. You're sitting there, there's a bug come in, it's got to be fixed, it causes major problems, and lo and behold, it will not happen with a debug build. It will not happen on anything useful. You put in some extra lines of code, you put in some extra logging, it will not happen. But those game testers, bless them, they will get that bug to happen time and time again, so you can't just pretend it doesn't happen. So what we have to do sometimes is we have to go and look at the assembler, because if you've ever looked at a release final build when you've got a bug, yes, you've got your source code and it shows you this lovely line that it's crashed on. Trust me, the chances are that is not the line that's caused the problem. You won't be able to see any of your variables because they've all been optimized away, and it just becomes a nightmare. The pointers, you might have 3 or 4 things on that line which are reading memory, and you've got no idea which one it is that's caused the memory read if it was a memory read issue. So quickly being able to just drop into the assembler view, being able to understand what's happening, even if you couldn't have written the assembler, being able to understand what is there means you've got more of a chance of seeing what that error is. And that will give you a lot of chance to fix them. A while ago, we had a bug that would always crash. It was always on, I think it was an ATI graphics card on a PC. And we actually had to go into assembler for that because it wasn't even a bug in our code. It was a bug in the driver, and obviously they weren't too keen to say it was their problem until we could provide an exact location and say, look, this is what's happening, this is what's going wrong. You would never be able to find bugs within the drivers because you don't even have the source code for those. So sometimes it is useful. And personally, I find assembler quite fun, so I'm just weird like that. But on all these things, it is the journey. As this says here, it's the journey that matters. As we said, it's very easy when you come against a problem to go to Google, type it in, Stack Overflow. Thank you very much. Copy, paste, and away we go. But then you're missing the purpose, you're missing the learning. If you have a maths problem and you just get the answer, next time you have a similar problem, you've got no tricks in your bag to be able to understand and apply to try and find that answer yourself. So all you're ever doing is going to go and keep getting the answer. You've learned nothing to apply, and you've got nothing that will help you when you have to write something new. So don't always look for the answer. As we progressed, this was on an Amiga. There was a game called Menace. Came out about 1988, so still before the internet. This was how we used to do scrolling. We started with screen A, we scrolled across, we drew new blocks, the same block at the start and the front, so by the time we got across to screen B, both screens looked the same. You could flip your screen back to screen A and carry on scrolling. This is how you could keep scrolling over and over again. Well, sometimes when you're learning, when you're going on that journey, you make mistakes. We all make mistakes. And one thing that could happen here is the code that resets you back from screen B to screen A goes wrong, and your screens go trundling off through memory. Might seem like a bug, but a game came out. Now, I don't know if this was the first game to use this technique. It was the first game I saw using this. I don't know if the programmer's here today. He may be able to tell me. But Zool, when it came out, was revolutionary in certain ways because of the speed in which it done its scrolling. Now, what it done was it actually used this idea of scrolling through memory. It didn't do this drawing at two screens. It used the idea of scrolling through memory to mean it was only having to update less information, so it could therefore scroll faster. There's a good chance, as I say, I don't know, I haven't spoken to the programmer to find out, but there is a good chance that that came about because while someone was doing a scroll routine, they made a mistake, they saw this, what was happening, and it just gave it that little spark. So again, if we'd just Googled, we just got the answer, this may never have happened. Often, while you're learning, while you're writing programs and writing tasks, those mistakes that you make will actually give you insight into ways to do things. Now, we all like shiny new things. We always like to start new routines and what have you. But sometimes they do become our worst enemies because you write a really nice routine. You've got a problem, you've come up with this solution, you've programmed it, it works really well, you've shown it to your other programmers, and they've gone, oh, that's a really good idea. And you get that little warm, fuzzy feeling. Well, great. Next time you've got a problem, you remember that, and you go, oh, I want that fuzzy feeling again, and that worked really well, so I'll use that again. And we're all guilty of it. It doesn't matter how far along the pathway you are. I would pretty much guarantee we all fall into the trap. As we moved through sort of time and we came on to delegates and all these new things, I think delegates came into C++ in version 11. This was a system that came around, has been used. I've used it a lot myself because it does allow for cross-system communication. When you've got a lot of people working on big teams and you're just working on one small element, you don't necessarily have the joy of being able to put the calls in to pass onto another system. So you've written some collision. The audio needs to be triggered when something hits it. What you don't want to do is end up with lots of calls between these systems hard-coded in there. So one of the things that comes around is delegates. So your code sits there and it goes, hey, something's happened. And anyone else can ask to be told when that thing happens. And it works really well. But I certainly have been known to overuse this technique. The problem with this sort of technique is it does work well in situations, but it does come with problems. So it's well worth making sure you understand the implications of the systems you're using and whether or not they are the right solutions. So in this case, you fire off, you ask to be told when one of these events happens, this delegate fires. You've got no control over what thread that gets triggered. Now, for those of you who have started doing, obviously most games now have multiple threads running, you can get into a lot of problems if you're suddenly trying to do something on a completely different thread to you're expecting. And the other problem with this is, while it may have, when you first put in this call to be told when something happened, it may have been running on, for instance, the render thread. So it's great, I'm going to kick off my Visual FX. Well, that's all very well, but you're just being told what happens. You've got no control over the bit of code that triggered it. That person may have to rewrite that piece of code and change when it happens. And now suddenly, your system's not working because that callback is no longer coming on a render thread. So when you start writing systems that implement these delegates and things, just be aware of who's going to use them and what things it can cause, what problems it can cause. You also get ordering issues. If 3 or 4 people are all listening out for the same delegate, there is no way to guarantee who's going to get called first. And on the project I've been working on, we have had issues where a delegate gets fired and it's told that a new user has started. The problem is then other people are listening out, expecting that user to have been there. And as you can see, it's all very well when it does happen, but if for some reason the order changes, it can cause an absolute nightmare. With functions and Lambda-style functions, there's also issues in that when you pass your function through, you might be using a call that gets a callback to say, everything's fine, it's all succeeded. Now, that's all very well, but what happens if that underlying function that you've called suddenly becomes asynchronous? You've been running it on a test system, and it's all fine, but now that piece of code is communicating with a web server somewhere. It's become an HTTPS request. There's a delay before that information comes back, and lo and behold, before the information comes back and you get your call back, the user's closed the UI, or something's happened, and the piece of code, the caller that passed that function in is no longer around. The piece of code doesn't care. It just says, it's all happened, it's fine. You're suddenly running some code. This pointer is no longer irrelevant because it's all been deleted. So a lot of these things come down to just taking time to think about whether or not this is the right solution for the piece of code you're writing and who's going to be using it. Are the chances are they're going to need it to be on specific threads? It may come better to things like this. It could be better to do a polling system. So you just queue up all the information that's happening and then allow the other system to ask when they're ready for it if things have happened. Another thing people use quite a lot now, smart pointers. This is some horrible code. Hopefully, if anyone wrote this code, someone would pick it up in a code review. But examples, they're not, here we create an object from a standard memory allocation, and 2 different people have created a shared pointer from it. Now, obviously, if it was in this situation, you'd see it quite easy, but in big projects, again, when you're working on big teams, this can happen, because 2 different people working in 2 different areas of code suddenly try and create a shared pointer from an object that may even come from an external library. This works fine until one of those objects gets deleted, or the reference count goes 0, because it will delete it, and because both were created from the same one, suddenly you've got a shared pointer, and it's sitting there pointing at random memory. So when using things, make sure you understand what happens under the hood of these. Shared pointers are great. They solve a lot of problems, but just be aware of what is happening. Other things to be aware of, how it uses the memory. Both of these are effectively fine. They both create a shared pointer from an object. The difference is, the first one will create 2 memory allocations. It'll do an allocation for an object, it'll do an allocation for the shared pointer information, the reference count. And if you're running in a tight piece of code, if you're running it in a time-critical thing, that can obviously have a big impact. Whereas the second one, it will actually just do all the allocations in one, so you're going to have a lot less memory overhead and implications. And again, if you're doing two allocations, both of those are going to end up doing alignment and other such things on platforms. We do still have to worry about the amount of memory you're using, and simple things like this, if you understand what's going on, if you've taken the time, this will help you. It'll certainly save a lot of optimization time later on. They are not pointers. Again, horrible function. I wouldn't expect to see this in the code. But again, because of big projects, what's happened here is we've got a cyclic reference, shared pointers pointing to other objects. If those next and previous pointers were also shared pointers, we would hit a problem because we would have a memory leak. It's a bad example, but to highlight it, because what we should be using is weak pointers for your next and previous. But again, it comes down to making sure you're using the right tool for the job at the time. And thread safety for a lot of things, not so much with smart pointers in this case, but with things like the STL libraries, people are very keen on the fact that most of the things within STL, lists and maps, they are all thread safe to a point. If you've got a list of objects and you're accessing it, a lot of the time, yes, we can say that it's thread safe. The problems come, the object that you're dealing with isn't thread safe. It's only the list itself. So you can still end up with two threads trying to access and change objects at the same time. And as I say, they're not pointers, so we're back with smart pointers. They're not pointers. When you're passing them between functions, it's very easy to forget that, and you can get big cache hits and big memory copies and things as you're passing them around. So just think about when you use the smart pointers, should you be passing references, other such things. And as we progress, as you move up, you do have to start, you deal with junior people, you have to deal with other disciplines. Probably not quite accurate, but the sentiment is there. It was attributed to Albert Einstein, but some people argue whether he said it or not. Make sure you understand it in being able to explain it. And this is where code reviews actually come in quite useful that we use. Going through code and explaining it to someone else, actually having to explain it to someone else ensures that you do fully understand what's going on in the code you've just written. It also helps because it's almost like going back to where we used to write things on paper. If you talk through a routine with someone else, you will actually spot things that you don't notice yourself. If you just look at the code yourself time and time again, you will see what you want to see. You will see what you expected to see. So try, as I say, if you can, try explaining it to someone else. And one of the best things you can actually do, and it's probably harder in some ways as a junior programmer, is talking it through with someone else and explaining it to someone else. You don't want to appear that you don't know what's happening, but you can't beat that communication with other people. Now, keeping it simple for future-proofing code. We all like really complicated routines that look fantastic, but they are a nightmare to maintain. Recently, I was looking through some code that I was having to use, and I was thinking, oh, this is horrible. Who on earth wrote this? Turns out it was me about 11 years ago. The only saving grace was it was something I had to write very quickly. It's not really a good excuse. But just because of something seems like it's going to be complicated doesn't mean it has to be complicated from a code perspective. And this can come back to, again, using good old pen and paper. Before you start your routine, plan it out a bit. Keep functions smaller. Back on Crackdown 3, for those of us that were working on that, we had a couple of horrendous files. We had one file, I think the C++ file was over 20,000 lines long. The header file was over 4,000 lines long. It was a big class, it was effectively complicated, but it had got unmanageably complicated because it wasn't planned out enough. It wasn't split up when it needed to be. When you get to sort of 4,000 line header files, nobody knows what's going on in there. You end up with like 5 copies of effectively the same function because nobody spends the time looking there. So you might have one function called isDead, and you'll have another one called isAlive. You'll have another one called getIsDead, and they'll be distributed through this entire header file. And trust me, when you actually get to the C++ file, it gets even worse. So keep your functions smaller, keep your files smaller. It's very hard when you're working and you've got deadlines, but as you add to a file, take the time to question, would this be better if I split this up again? When you add another class, it can be easy to put it into the same header file, especially if it takes time to add them into a build system. But it's always easier, especially if someone else has got to come in later on, to put those, each class, especially if it's its own entity, into a file that's similar named. It just makes life a lot easier to find them. Comments. We all love comments. I'm terrible at putting comments in sometimes. And sometimes we do put comments like this picture. How many of us have put int equals 0 and then put the comment, sets it I to 0? We all do it. But meaningful comments do help. You at the moment you're writing it, yes, it's all fresh in your mind and you understand it all, and you think, why would nobody get what's happening here? Trust me. You come back to that code in 3 months' time, try and remember what you were doing, it's quite hard. And as you work through, we are certainly having to go back to code we wrote. As I say, I've come across a file I wrote 10, 11 years ago. It is very hard to remember what you were doing 10 or 11 years ago. So those comments do really help. The problem with comments is you might write them when you're first doing the function, but you come back later and you change what that function's doing. Well, update that comment. The number of times you'll go into code and you'll see a comment and you read it and you look at the code and it doesn't make sense because what's happened is someone's changed what they're doing and hasn't updated the comment. Similar things, sensible naming and maintaining the names. This is especially pertinent if you're using header file, changing something in a header file, because we all know every project has those header files that you dread changing. You make a change on that header file, you know you've got about 35 minutes plus of waiting for it to build. And you're on milestone week and you're running late and you want to get it done, so you think, oh, I'll just change the function. I know the function's called, like, say, isDead, but I'm going to make it so it does a load of other things. Well, it may seem to have saved you a lot of time there and then, but trust me, it's going to add a lot of time to the project because somebody else is going to come along, see your function that's called isDead or whatever, and they're going to use it, thinking that's what it does. They don't realize that you've actually changed the entire purpose of the function just because it was going to take a long time to compile because you wanted to change the header file. But then they're getting bugs. So try and maintain those names. It is hard when you're on milestone week and you need to get things done. We always go, oh, I'll go back and change that next week once the milestone's done. Trust me, you never do. And lastly, probably the longer you program, probably the longer this becomes true, about trusting your gut. Because, as it says, it works out what your head hasn't figured out yet. Now, for many years, and you'll hear many programmers say it, I've got a gut feeling, it's just something's not right. And it turns out someone did do some scientific research into this. And it is true. The only difference is, it's your limbic brain, it's not your gut. But there is a reason for it. As you spend more time programming and you write more routines, your subconscious mind actually takes on board what's going on, and it will actually analyze what you're doing to a certain extent before you even realize what you're doing yourself. So when you get that feeling that something isn't right, stop. Take 5 minutes. If you need to, go back, write some stuff down. Just check that everything you're thinking is actually going to be right. Again, if need be, find someone else and talk it through with them, because they may be able to see what you haven't noticed. But you'll save yourself, it may cost 5-10 minutes to sit back and think, go grab a coffee, come back to it and read through it and think about it again. But it saves a lot of time rather than just powering on and causing yourself a lot more problems later on. But with all these things, as we said, the journey is what matters. My journey along the programming pathway has taken me into many different ways and areas of programming. Each of you will have a different journey along the pathway and through programming. But the biggest thing you can do is question. Question what you're doing, question why you're doing it, question what's happening. Don't just want the answer. The answer gives you no learning, and it's the learning that will help you as you go along. So with questions in mind, thank you very much. Is there any questions?
So the advice you gave first up in the beginning of the talk, where you recommended to get familiar with assembler, do you think that applies to languages like C# and things like that, where there's like an intermediate language?
It's harder with C# because you don't have assembler as such, as you say, but the process of, even if you just play around with a bit of assembler, it makes you think about in more constrained environments. You are a bit more limited in how you can do things, and the logic that you have to apply is a bit different. So I think it's still relevant, and there is always going to be times when we come into languages that aren't like C# so that you can hit the assembler. And bizarrely, we do still use assembler today. It's just people don't seem to recognize it as much. If anyone's used like intrinsics, they are sort of like assembler. They're quite often assembler. But yeah, for things like C# managed languages, it's not so much useful for the debugging, but there is still some use there in the process of understanding, because you are effectively talking much more direct to what the computer would do. So it does help you think more about how the computer is understanding things.
Hey, Adrian. Can you hear me? Yeah. So when you said that we need to have the familiarity with the assembler, especially when it comes to debugging various codes, there was one time that I had a look like that and kind of realized that various compilers outputs assembler code that has no similarity with each other. For example, like Microsoft Visual Studio's compiler has like one kind of code, while GCC compiler has like ultimately completely different one.
Yep.
So if we were to go down that line, how do we keep up with all this various different kinds of compiler outputs? And do you have to learn more than one different sets of compiler instructions?
At the end of the day, the compilers do produce very different code, but as long as you learn what the instructions, effectively the assembler instructions, are doing, you can still quite quickly see where it's come from your code. There is a bit of a knack to it, and unfortunately the best way is just to try and play around. It's easier if you're trying to learn to actually use debug builds, because then it is sort of a one-to-one correlation. But yeah, it is hard when you're going between different compilers, because they do change things quite drastically. Some use stack more, some try and keep things in registers more. But it's more being able to understand the instructions, and even things like knowing what registers there are. On PCs, it's weird because you have things like AL, AX, EAX, RX. They're all effectively same things with different sizes. So they're like from the 8-bit, 16-bit up to 64-bit version. So it's learning how to read the code more than learning what the compiler has given you, or like on a one-to-one correlation. It's being able to understand what at that point is happening. So you can look at the code and go, that's most likely this pointer. If you've got 3 or 4 different pointers that are being read, you can get an idea of which one is the one that's got a null pointer or something like that.
Would you have any advice for somebody who is just trying to get his feet wet with, assembly language? Like, where to start?
It's quite hard nowadays. It does have to be said. The best thing to do actually is just look at some simple routines. There is quite a lot. Although I say using Google can cause problems. There are a lot of good information on there with simple routines to start with. So pick an idea. Don't obviously pick a game and go, I'm going to write a game in assembler. But just start with some simple routines. In some ways, I would say it depends on how much you want to learn the assembler. In some ways, it's easier to go back to slightly easier processors. You can go back to the Z80s and the 6502s that I started with. The instruction sets are a lot easier. It's a lot more contained. PCs, the instruction sets have grown so much. But once you've learned, it's like any programming language. Once you've learned one, being able to move on to others becomes a lot easier. Because they all work in the same way. It's then just learning those finer nuances, like when you've learned C and you move on to C++ and those sort of things. It's just learning the slight variations. So sometimes, consider starting the earlier ones. And obviously for those of us who work at Sumo, we get learning days, so it's a great use.
Thank you. Adrian Otis then.
Not a question as such, but I was just going to say, so Intel actually do really comprehensive documentation. If you just Google around for the Intel documentation on stuff, the reference material is incredibly heavy going, but they do take pains to do some introductory stuff on that just, like Adrian says, just getting to know the registers and the register layout and stuff. Just hit Intel directly on a chunk of that.
So there's, if you really want to, I know I'm probably quite geeky, but if you really want to, I think there's a Udemy course at the moment that on how to write Atari 2600 games in 6502. So if you want to write a game, learn assembler at the same time.
So I was probably just going to add, further to that as well. You can always just break in a debugger, and you can open up the assembly view and step through at the instruction level, and also keep an eye on the values in the registers as well. And that might be a nice way to try and pick up on what's going on as well.
If you do that, because you can get the mix, so it will show you the C line, the C++ line, and then the assembler. If you do that, though, do make sure you're on a debug build, because otherwise it gets very confusing very quickly.
At the risk of just this turning into a how do we learn assembler discussion, but that's still probably quite valuable. One resource that I used when I was young was a book called The Art of Assembly. I think it's free. It's a bit dated, but it's almost, you could treat it like a university course. But crucially, for me, the important thing about understanding this assembly is not the language, it's knowing how a CPU works. And when I was about 10 years old, I tried to program by concatenating COM files together because I didn't know how to program, and strange things happened. And then I moved to BASIC, and I still didn't know how a CPU worked. I knew there were things called variables. I didn't know where they were or what they did, but only when I sat down and actually learnt what a CPU does did I get a better understanding. Now, of course, the electrical engineers here will say, well, even that's a lie. And when you go even further down, you realise the world's not quite what you thought. But this book was very good at that. It spent a whole chapter just saying, what is the CPU? And then another for the math nerds of, well, what is Boolean algebra? And I found that was quite a good grounding that you can then use to learn a variety of assembly languages or just understand how the CPU works.
Yeah, it's like with anything, and again, as you're progressing along a pathway, it's like it said on the slide, it's not forgetting the past. It's very easy to skim over the top of things, especially when you're working day to day because you've got tasks and that to do. But it can be fun to take time to drill down, to assembler. Like Mark said, learning more about how the CPU works. Maybe don't take it as far as I've done and actually build a CPU out of 7.4 series logic gates, but it is quite interesting. You do start learning things. There's some quite weird tricks as well, like you can do swapping of two variables without actually having to use memory, but with just two registers by doing XORs and things like that. So it's good fun.
So one of the things that we often ask our principal programmers to do is just hop around the code base and fix bugs wherever they happen. Have you got any hints or tips on how do you get up to speed with what a particular section of code is doing when it's literally the first time you've come across it and there's a huge wall of existing stuff in there?
I mean, one of the biggest things is read the comments, but that relies on people, as we said, putting the right comments in. It is true, as a principal, you do have to jump into code bases and sometimes literally millions of lines of code that you've never seen before. Debuggers become very, very, very friendly for you. Literally sticking in breakpoints, seeing what's happening, seeing what's going on with registers, single-stepping through some stuff. Quite often, you are reliant, if you haven't got long, you are reliant on what the functions are called, what the comments have been in that file. But yeah, it's again, it comes down to having an understanding of the language. So if all you've done is copied and pasted from Stack Overflow, you're going to struggle. So make sure you do have an understanding of what's going on, because that will help you. Making sure you do have that in-depth understanding of what you can do in a language, because we all have our very own styles of programming, which is why probably the most controversial document in any company is the coding standards document. I don't think any one person in a company actually likes it. We all want to change it very slightly. So, but get familiar with the styles that. If people have conformed to a coding standard document, it's a lot easier. But just reading code. Read other people's code. Take time to flick through code bases now and then, and take time to, as I say, single step through things, stick on breakpoints, jump in. Change some stuff. Every now and then, just change some stuff to see what happens. Obviously, we're running a bit out of time. I will be upstairs if anyone really wants to come and talk about anything. If anyone wants to reminisce about old Z80 or 6502 or any other machine code, I'll be up there as well. So, yes, thank you very much for your time. Hope it was useful.